Hello everyone, welcome to this video tutorial on analysis of truss elements or analysis of trusses and using finite element method. We'll be using ANSYS Workbench as a software tool or FEA tool to analyze the trusses. So after watching this video or completing this video tutorial, you will be able to model the truss members in ANSYS Workbench. Then you can apply various boundary conditions on the truss elements and you can calculate the deformation, reaction forces and axial forces in the truss elements. Now, so this is the problem we are going to solve. We have three members, member AB, member AC and member BC. So member AB is 3 meters long, then member BC and AC, the lengths are not given, but the point C, the location of point C is given, that is 1 meter away from this member AB, and point C from vertex A and vertex B is at the midpoint, or we can say 1.5 meters. And the forces are like this. You can see 10 kilonewton force is applied at a point C at a 45 degrees Celsius, 45 degrees. Sorry. Then this vertex A, this truss is fixed at vertex A, and we have a roller support at point B. Now, material properties are not specified here, so therefore, for this analysis, we will be considering structural steel as a material, and also the cross sections of the member are not specified, so therefore we will consider a circular rod of a radius 0.01 meter in this analysis. So let's move to the ANSYS Workbench. So this is the user interface for ANSYS Workbench, and then you have to select the static structural analysis for this analysis of trusses. Now the first thing is that you have to model the engineering data, that is material for this analysis. So double click on this thing and we can see here by default we have structural steel as a material selected for this analysis. Now if you have to select any other material, you can go to engineering data sources and then you can select material. You can add the material from this library here. Okay, I'll show you one thing. So we want general materials. In general materials, if you can use this aluminum alloy. You just have to click add and that's it. So you can see here this book type of icon. Now you can see this materials added here. Now you can select any of these two materials, but as we have discussed that we will be going with the structural steel, I will suppress this aluminum alloy. Okay, so just close this and we'll go to the modeling of the geometry. Now in ANSYS you have three options. You can model the geometry in new discovery geometry, that is user interface. And then we have this space claim geometry and we have new design modeler geometry. So in this analysis we will be using space claim geometry. So click on this thing. Now it will take some time to open space claim. Just wait for some time, few minutes, let's say 1 or 2 minutes, and the space claim will open. It takes time, but yeah, we are on. Okay, so there's a warning, you have to neglect it. Clear. Okay, so we are in a sketch module of this space claim, design space claim, and we have several options here. So this is structure. You'll see a tree here. Then we have layers, sections. We don't have to deal with this thing. But the very first thing, what whenever you are analyzing the trusses, before starting of sketching, the first thing what you have to do, you have to click on this layout sketch. When we will select this curves from this folder, will be created as a layout curves, which does not automatically fill or imprint into the faces. So whenever we model trusses, there are triangular shapes we generally model using the line elements. and if we don't click on this layout sketch, it will convert those that filled area as a surface. We don't want that area to be converted to surface. We want to analyze the line linear elements, I can say. So you must click on this layout sketch. Okay, so after clicking on layout sketch, we will go to the designing of this truss members. Now the first thing that you have to select the plane. To select the plane, you have to click new, select new sketch plane. And now we have selected this y plane or xz plane. You can see here, this is the bottom plane. Now we have to select xy plane. So to switch to the plane, you have to select click on this new sketch plane selection. Then you can just go to this thing, and now we have selected this xy plane. This is the yz plane and this is the xz plane. So just click on this. Here you can see I have selected xy plane and z is perpendicular to that xy plane, or we can say this is also a z plane. Now we have selected the plane. Now what we want this plane should be parallel to our screen, and this z axis should be perpendicular to our screen. So to do that, you just have to click on this plan view, and that's it. So the plane xy plane is oriented parallel to the screen. Now I can start drawing the lines. Before that, we have to select the units. So click on this file menu and go to space claim options, and after after this opens, you have to click on units. Length, we have to select in meters. So angle will be in degrees, or just click on this thing and we'll click OK. So that's it. So we have to first of all select the units. After selecting the units, you can go to line and you can start modeling the geometry. Now we'll start with this point. And what is our first member AB? Member AB is of 3 meters. So just click 3 and click enter. So your member AB is ready. You can see here, member AB is ready. Now what we have to do, we have to locate point C, and point C is from midway 1 meter away from this midpoint. So how to locate that point? We will select this construction line, go to this midpoint and select a line of 1 meter. Create a line of 1 meter. That is a construction geometry. You can delete it later. Now again select a line, click on this edge and go to this edge, click on this edge and go to this edge. That's it. So we have modeled the geometry. Now I will delete this construction element. Now that's it. We have done with the geometric modeling. Now what we have to do, we have to assign a cross sections to this member. So this is member 1, 2, 3, we can say. We have modeled the members. Just click on end sketching. Done. Now what we will do, we'll go to the prepare option to prepare the cross section. Now in prepare option, we have several things: analysis, remove, detect, beams. So in this beam options, beams, we have several profiles. Now you can create a new profile, or you can directly select it from standard library. Now as we have said that we'll create the circular or rod for this thing. So we have selected, or we have to select this circle here. Now as soon as you select this thing, you can see here in the tree a beam profile is added. Now so in the structure, you can see here we have circle profile. You can edit that beam profile if you want, and you can see here in a new tab as a circle. You can edit this radius from this option. Okay, let's see where it is. Drawing dimensions here, just how to make a space, and ruler dimensions. So you can see here, you can increase the size, but as we have decided that we'll go with 0.01 meter radius, that's fine. Then close this circle. Now what you have to do, you have to apply this beam profile to all these elements. in the sketches. So what you have to do, you have to click on this arrow here in sketching plane, and then you have to go to this arrow again, and you can see there are 3 lines. We have to apply this beam profile to these 3 lines. So click on the first line, click on press the shift button and click on the last line. So you have selected all these 3 lines. Then what you have to do, you have to just go to this circle, or you can click on this circle or this circle also. So you click on this circle, that is profile, and that's it. So you can see here a new tab is added, or new tab is added to this structure, you can see, and it says that we have this beam structure here with this beam structure here. You can see here, this is the beam structure, this is the beam structure, and this is the beam structure. Now as you know that we are analyzing the stresses, and these are the beam structures. Beams can take the lateral loads, and we want trusses, this to be trusses, and trusses should take the axial loads only. So how to convert this beam to the trusses? So you can select this thing here, select all these beams, okay. Then go to this properties option here, you can find the properties option here. Then beam type, click on this type, we have beam, scroll down here and click on link and truss. So this is how you can do it. Now you can see here that beam type is link or truss. That's it, done. And you can see also here that is truss circle, truss circle, truss circle. So that's done, preparing the profile. Then we will go to the workbench. In the workbench module, you have to click on this shear option. So shear coincident topology means that you will be sharing these vertices with these links, okay. So just click on this shear, you will get some message. You can see here, you will get an information found 3 vertices. So what are these vertices? This is the one vertex, vertex 1, vertex 2 and vertex 3, and you just have to share the topology among the vertices. So just click on this and that's done. You have done the modeling part of this or design part of the truss. After, as soon as you do this sharing option, you can see the color of the members change to green and the vertices change to blue. That's it. So don't bother about the color of the vertices, but this should be turned green, okay. Then you just close this design modeler or minimize it, and you can see here the geometry we have okay or green tick option. Now let's go to the slides. What we have to do, you can start model, click on model and let it open. Start this, this is showing that starting mechanical. Till then we'll go to the slides. We'll go to the slides. So we have done with the cross section assignment, and this is the mechanical or model started mechanical workbench. We'll just go to this thing, yeah. So we have done with this material assignment, then material selection and cross section assignment to the members. Now next thing is meshing. So in the meshing we have to give a size 1 element per member, and the type of this element is link 180. That is the name of that element in ANSYS. It has 3 rotation translational degrees of freedom at each node, and this element can be used to model the trusses, sagging cable, links, springs and so on. So the more information about this you can find out on this thing here. So let me that's it. So this is a link 180 element from the ANSYS documentation. You can find more information about this element in this documentation. I'll give you a link of this documentation for this link 180 element in the description box. Now let's go to the model. See, okay. So this is the mechanical ANSYS mechanical workbench. This is the user interface. We have a model here and some of the details of model A4, and this is the, you can see here whatever we have geometry we have modeled is imported in this static structural mechanical ANSYS in this module. Okay, now we have this project model A4. We have imported the geometry. Geometry is nothing but the truss circular elements. We have material structural steel. We have cross section circle, and we have geometrical global coordinate system like this. Now the next thing is we have to mesh. Now to mesh, as we know that we have to use one element per this member, and we have to use the link 180 elements. So to mesh this thing, we have to go to mesh, right click on mesh, insert, and go to the sizing option. Click on sizing. Now you have to select this geometry, all these three members. So there are two options. The first one is to select this geometry. The first one, there are two modes I can say. The single select option is there and box select option is there. So I'll show both the things. Let's start with the single select option. We have selected this mode. In this, after that, what we have to do, we have to go to this vertex, edge, face, and body selection modes. So from this four, we will select this edge because these are the edges. Now click on this edge, then click on control or press the control button and select all these three members. So this is how I have selected all these members. Okay, now if we want to see the second mode, you can go to box select and you directly select the box, select these members using the box. Okay, after selecting this, you can go to this geometry, you can see here, and click on this apply. Now you can see here, as we see that we want one element per member, and there are several elements per member, and the size of element size is given default 0.15 meters something meter. So we have to change this thing, and to change this thing you have to click on this type. This drop down menu will appear, and you have to select number of divisions, and number of divisions will be 1. Okay, so that's it. We have done with the meshing, and if you want, the behavior is soft, no bias. Now the element will be automatically selected. You need not to bother about the type of element, it will be automatically selected. Okay, so just click on generate mesh, and that's it. So we have done with the meshing. You can see here the type of the element is reflected here. You can see the various options how to change the shaded edges, how to change the look of those elements. Okay, now the next thing is we'll go to the slides. We have done this meshing, then we have to apply the boundary conditions. So let's understand what are the boundary conditions first. At the node A, this vertex A, we have fixed boundary condition. At the vertex B, we have ruler support. Now, for the fixed boundary conditions, the displacement along all the three mutually perpendicular directions are 0. That is ux, uy, uz is 0. And for ruler support at a point B, we have ux allowed. That is the motion along x direction is allowed, but uy and uz is 0. The star point is that uz is perpendicular to the plane of the screen, so it is not shown here. Now let's go to this thing, mechanical, ANSYS mechanical. Now to apply the boundary conditions, you have to right click on the static structural insert option is there, and then we have to apply the fixed support to this point. To select this point, you have to switch to the mode single select and vertex. Single select vertex, you can select this point and you just have to apply the fixed support. That's it. You have applied the first boundary condition. Okay, then we'll go to the next. Again, right click on static structural insert. After that, we have displacement boundary condition. So displacement, Now you have to select the vertex. This is the vertex. Now you can see here, you just have to apply first. Then you can see here, all these three components are free. All these three components are free, and we want only x component to be free, and y component we have to restrict the motion, z component we have to restrict the motion. So we have given this free 0 0 displacement conditions on this B. So this will move displacement along the x direction, but it will restrict movement along the y direction and z direction as well. Okay, so that's it. We have given the boundary condition. Next part is we have to apply the forces. So let's go to this forces. Okay, now we have a force at point A. So this is the 10 kilonewton force applied at 45 degrees from the horizontal. Now we can decompose this force in the two components. The first one is along the x direction, that is 10 cos 45 degrees Celsius. Sorry, not degrees Celsius, that is degrees. 10 cos 10 into cos 45 degrees kilonewtons, and in y direction it is minus 10 sine 45 kilonewtons. So let's calculate this forces first. We have to go out of the full screen mode, escape, and full screen. I'll just do it like this. Now let's open the calculator. We want 10 into 10 to the power 3, that is 10 kilonewton. Okay, now into cos 45, that's cos, go to the basics again, 45, and then this is the amount. Okay, see, we'll see what is the cos, what is the amount for sine 45. It will be the same, I think so. It is the same, sine basics 45, the amount is same. Okay, as sine 45 and cos 45 are the same. Now let's close this thing, toggle to the S here. Now we have to apply the forces. Go to the right click on the static structural again, insert, and we have force options here. So force, again you have to select the geometry. Geometry will be this node, apply OK. Then okay, that will be here. Instead of defined by vector, you have to use components. Okay, then the x component is nothing but this, and the y component is minus 7071, because it is downward in y direction. Okay, you can see here, this is the force applied, 10,000 Newton, that is 10 kilonewton at 45 degree from the horizontal. Okay, so that's it. We have given the support, fixed support, we have given the displacement, and after this we have given the forces. So we have applied essential as well as force boundary conditions. Okay, then we'll go to the solution. Before that, we'll go to this thing. So we have modeled the forces, and we want this full screen. Okay, so these are the results. If we do it manually, we'll get the uh, tensile forces or reaction at A and B, and the forces in the members. So these are the values. We will validate them later. So what we want, we will calculate the total deformation at each node, the reaction forces at A and B, and the axial forces in each members. So how to do that? Let's go to this ANSYS mechanical thing. On the right, on the solution, you have to right click, insert. We have deformation, total deformation. Then right click, insert, and we have probe option, force reaction. So after selecting the force reaction, this menu will appear, and where we have to find out the forces, reaction forces. So first one we will select the fixed support, then again we'll add probe, force reaction, and this time we want it at a displacement here, boundary condition, displacement boundary condition, and then the last thing is that we want beam results at the axial forces. Okay, so as this is a truss analysis, in the beam result you will not get bending moment, torsional moment, shear force diagram. So if you want to see this should be 0, we'll add it, and we'll add it, and we'll add it, but this all should be 0. So this, sorry, bending moment, torsional moment, and shear force will be 0. Okay, now let's right click on the solution and click on solve. So it will take few minutes to solve. The number of elements in the model are, this is the warning, you have to neglect it, that's nothing serious about it. Okay, it's evaluating the results and it has given the results. So let's first see the total deformation. This is the value of total deformation. I think we did something, or let's say that's correct. Okay, so we just have to analyze the results. Now what is the maximum force, maximum axial force, that is 8.83 kilonewton I can say, and this is the member, corresponding member. So minimum is that, so the force is in minus, that means the member is in compression. So these two members are in compression, this member is in a tension. So the, let's check with the, what is our result. So okay, force in AB is 8.84 kilonewton, and we have got this 8.838, that is 8.84 kilonewton here. Force in this is 10.62 kilonewton, and it is 10.62 kilonewton. This minus sign is same as we have got here, and force in this member is around in between minus 1.9 kilonewton to 4.1 kilonewton. So that is 2.13 kilonewton. So you can see here, if we add some more, now the number it changed again. I don't think so it is possible to exactly look it, but now you can see it is near to 2.5 kilonewton. So it is nearby only. Okay, now that's the that is the axial forces. Now we'll go to the force reaction. So this is the force reaction at point A, that is the final result, but what is in x direction? So that is in x direction minus 7.07 kilonewton. So minus 7.07 kilometer, sorry, kilonewton, and 1.178 kilonewton. So minus 7.07 kilometer and 1.18 kilonewton, 1.178 kilonewton, that's pretty much nearby. Then the at the point B, the reaction is 5.89 kilonewton, 5.89 kilonewton and 5.89 kilonewton. That's correct. So we have got the results, which is if we compare with the analytical results, are pretty much similar. Then we'll go to this thing, and we have added total deformation. This is the value of total deformation. Now we'll check what is the bending moment. So you can see here, this is 0, torsional moment is 0, and total shear force is 0. So as we know that these are the truss elements, and truss element don't exhibit this behavior of what I can say, it doesn't take bending moment and torsional moments as well as shear forces. So those are results are 0. You can see here the animation of this thing. So this is how truss will behave based to the apply upon application of the applied loads as given. Now if you want this results, you can click on this images and you can click figure, you can apply figure. Now axial force, you can see the figure here. If you want, you can copy this figure, copy to clip board option is there. Again, if you want image, you can add image. So image is also there and figure option is also here. So you can copy this figure and try to paste it somewhere. Let's see. Okay, is possible? No, values are getting copied. Let's go to this thing. No, double click. So no, this is not the video. Copy to clipboard. Yeah, here this we have option of copy to clipboard, and we go to this thing and try to paste it. No, it's not getting copied. How to do this? This is image display selection automation. I did it once. Yes, selection to images. You can say use this save picture as option and save it wherever you want. Let's say truss axial forces and truss, and you can use the option png bitmap, whatever you want. Let's save it truss results, and save it here. Let's see how we can retrieve that thing. We go to here, then insert picture this device and truss analysis of truss results. You have this option. Okay, yeah, so you can import this image as well. So let's do something. You cannot see this image properly, so delete this thing. Okay, and now what you have to do, you have to do this like this. Now you can see each and everything in this, and then click on you can directly go to this images and image to clipboard and directly paste it. Now this is the option. Okay, so you can this will help you to prepare the reports as well. So you have this total deformation, image to clipboard, and duplicate, delete, and V, control V, then go to yes, then what we want, force reaction here, and we want a tabular data as well. So is it possible? Plane from image, plane from file, image to clipboard. Let's see what happens. So we have this result, but we want the data as well, tabular data as well. So how to, is it, no, combine chart, graph, we don't have the graph, force reaction. So this is the table, and I want to export. Yes, retrieve this result, or export option is the text file. You can use Excel file, this PC, and this PC, then you go to this thing, MIT, you want this results and reaction. Directly write a reaction at A. Save. Then you can go to this. It's running something. Then you can go to this and can directly go to this table options again. Tabular data. Export. Again, go to the same folder. This is results and reaction at B. That's done. Then just now you can insert a table of these three values, or you can import the table. I think so you can import Excel spreadsheet. Yes. But insert, import data, get external data. Refresh all. Is it possible to open? Yeah, open. No, we don't have option to open, so we just have to open. Go to that folder. Escape F11. Yeah, here are the RB and RA results are available here. So this reaction force at Z, we just have to copy and go to this thing and delete this and paste it here. So these are the reaction forces for A total. Then we'll add a slide here. We'll go to workbench, sorry, this thing, reaction forces, this two. Let's copy image to clipboard, then paste to this, the second control V. This is the reaction, and delete this thing. We have RB here. Okay, then you can copy this thing and you can present it like this. So that's it from this video. Okay, we'll meet again in the next analysis. Okay, thank you for watching this video.